So guys, let's start. Let me just check it once because lately there had been a audio issue. Hello chat. Am I audible? Do my voice is clear? Okay, I think it's working fine now. I think the audio is pretty clear. Let me just confirm it. Yes. Okay, now it's working fine, right? Now the audio is crystal clear. Okay, so let's start. Today we are gonna do this bipartite graphs. So here is our first question. This is the basis, the like bipartite DSA pattern. I have just tried it once, but I will do it again. So we got the question here, and one second, just a second, then. Okay, now let's go. Just a second. So this bipartite graph, it's like one of the essential DSA patterns, right? Many problems appears from this topic. I will be like going through all those patterns, but I will be starting from the very basic. And So guys, let's start. Uh, One of my friend came for that important talk, so we had some talk. It was related to placements and academics, so yeah, I had to give him some couple of minutes. Okay, here we go. So we have to just find here is the graph is bipartite or not. So this question essentially is like checking the graph for the bipartite condition or not. So let's start. First, we will initialize a vector name color where we will track uh, so where we will track like is it visited, or if it's visited which color is it. We'll be tracking the color and the visited thing. Let's take it int n equals to graph dot size. So this is the thing. Initially, I will be initializing it -1. Then we will check for every node, like every node. Yes. Now, and then I so we will check if color if is it is not visible. So first we will do with BFS. Then we will do using DFS. And there is third method which is of DSU, but I have not studied yet. After doing some couple of questions I will jump into that part, but for now I will be doing with these two methods. So yeah, if it I will be checking first. I will be doing with BFS. So BFS will take starting node, then that color array and graph. It Okay, I will have to convert it into adjacency list. So I have to first construct an adjacency list, right? Return true. Okay, let me just construct adjacency list for int I equals to 0, I less than n, for for ampersand, for auto ampersand it, it will be graph of it. So what how we are given a graph like 0 is connected to 1, 2 and 3. So adjacency list, yeah, I forgot to like initialize one vector of vector int dj. I think yep, now it's fine. So u and v, we will be taking u and v, adj. Let me just do it for loop using it for int it int j is equal to j less than graph. Nah, okay. What I was doing, dot push back will be there. Back it, doing it in the right way. I don't know what just stuck into my mind. For auto, dot pushback it है ना, then I will be 0, so 0 will be 0 to 1 2 3. Okay, this will be fine. Okay, now let's make that bfs function. Tool bfs can start comma vector and ampersand color is then vector of the and ampersand adjacency list. Now what I need to do, okay, color of, now I can like set a random color I equals to 0, then I need to initialize q dot push start है ना. Now I need to iterate it while not q and node is equal to q dot front dot adj of node है ना. Then if color of equal -1, then color of not dot color of and q dot push it. Is it right? Yes. Then else if color of it node. So if we found that same nodes are there, then I have to return false. Now, otherwise I have to return true. This is the thing. What did sometimes these blunders don't know how this blunder happens. That is the issue. Let me just copy it and just get. I need to make a private function. What is this? Where heck has it? Let me just copy it from this part and the rest of the part I will, because sometimes I feel lazy writing these codes. Nah, yeah, it's BFS Let's again put the file and start vector in percent vector of the adjacency list. Yeah. Now, color. I need to uh, set the color of the node. So yeah, start equal to 0, hit 0. Then I need to initialize queue. Then I need to push the first node. Then I have to create using queue. So node equals to queue front, queue pop, for auto IT a node and node. If color of if that node is -1, that node is -1, then simply color it to different to its parent and push that node. Push right. If that is not -1, the color of node is similar to color of its parent node. So I will return the false here. Otherwise, I'll just return true. And I hope it's gonna work. Let's see here the compiler error. Not Q. Okay. No, it's not globally, it's locally. Is there again any issue? Again, that what's the mistake here? It I is equal to 0, I less than n, and that's fine. That's fine. Start equals to q.fun.pop, and its color ID equals to of color ID color of, and return false. Everything looks fine, then why it's causing error? What's the issue here? Let me just debug it again. Adjacency list is given here. I was doing that time 0 to 1 2 3. It's q. I have just pushed it here, then check condition. Then this node is here, that q.front. That's it. Then I'm checking for its neighbors. Okay, the color of like it's if it's not visited, then will be that otherwise if color of that node is similar to its parent, then I have to like return false. This is the thing, will return true in all the respect. uh, Fine, then my opinion it's right. It's not gonna make any sense of changing the color, but why? uh yeah, I need to debug my own code this part time. N equals to graph dot size, right? Doesn't matter. So this is it, n and minus. It's named from 0 to n minus 1. Is it that adjacency list is also given? Why it's an issue here? Is this? I don't know, like, what's the mistake? We start, it's my giving it I0, I less than. This is not visited, then only I'm doing it. Returning. Okay, return here. Where is the mistake? Yeah, come on, just let's get it. Yeah, not able to figure out like what's wrong here in this code. Everything is looking fine. This crowded size. This is here initialize. Uh, then I'm checking each of I am taking care of the disconnected components as well. And here not BFS here. I'm doing the BFS part here. And I have queue also, and it's pushing that starting node. Color of IT equal. Then this part will be executed, and color of this, like the visited node, will be equals to the inversion. inversion of that color of the parent node is also same thing. Or I'm not getting it. Same thing I did it and yeah, I'm not getting it equals to one. Still wrong answer. Tell me, should I take this PT? Need to take it, yeah. If there is any logical flaw, shit, shit, shit. I have to push it that unvisited node, yeah. Now it's done. It's done now. Now I'm gonna like start it like with the DFS. Okay, I can do one thing. Like I have another question and I will solve it using DFS, and that is problem number 886. Let me just yeah, I need to like make it into here I have to construct a adjacency matrix, sorry, adjacency list. So that adjacency list is created. I just need to write an a DFS function. So I will just write a DFS function, tool DFS, and start comma and color comma vector of color है ना, then vector of instant adjacency list. What here, why it's not like it's not visible? It's visible now. Now my video is visible. So in the depth first search, what I will do here, mm, color of that node will be given for auto IT. Okay. Yeah, what I am going to do, if color of the, let me just make the font a bit larger. So yeah, if it is unvisited and if not of DFS, like IT not color J, then return false. and then the same condition, else if possible by partition, right? Else if pillar of IT, what is my parent and no? Yeah, it's the parent, no. It's simple like its color, है ना? Then also return false, otherwise return true. Okay, it's working fine, right? We can also use that thing. It's at various companies. Okay, let's submit it, and we have just completed two things. These two questions are identical, है ना? Here we have to just like get if the graph is if the graph can be a bipartite graph or not. And in the previous question, it was just a direct question. Again, that thing has happened. Why that hellish thing is happening? Sometimes it just switched to. Is there any hotkey? I think I got why it keeps switching frequently. I got it. Yeah, I will like make sure it will not happen next. So two questions. We have just done two questions. Like I have just revised it because today I have studied these questions at the college, and I think, and then I thought ki I will be like 705 was similar. Then we are going to do that problem 1042. Okay, that's problem 1042. So we have got a challenging problem here. Let me just check voice once because sometimes it's breaking in between and it just ruin the. Okay, it's fine. Working. Just a second. Okay, so let's read this problem and wait. Let me just connect my iPad screen. It will just take a couple of more. I hope it's about to come, about to get live. Okay, now just uh, setting resolution. So yeah, and okay, now iPad window. So let's jump into this question and what do this say? Hmm, What is this? Like, so we have n gardens labeled from 1 to n and an array paths where paths I is equal to xi and yi, which describes a bidirectional path between garden xi and yi. In each garden, you want to plant one of the four types of flowers. Okay, out of four flowers, we have to plant one flower, and all the gardens have at most max to max three paths coming into it or leaving it. Okay, your task is to choose a flower type for each garden such that for any two gardens connected by a path, they have different types of flowers. Okay, return any such a choice as an array answer where answer is type of flower planted in the ith garden. The flower types are denoted 1, 2, 3, or 4. It is guaranteed that an answer exists. Okay, okay, then every garden has at most three paths coming into it or leaving into it. Let's see, the topic will be staff, PFS, BFS, graph theory. Give it. Okay. I'm just think how I can do it. Ah, we can do one thing. Second, just a second. Okay, I can do one thing. Uh, I will be. There can be four states, है ना? Not four states. First of all, let me just construct a graph. First of all, we have an garden. Paths I is equal to xi to yi describes. Okay, 1 to 2. It's given like 1 to 2. So, they are nope, nope, close. So, let me just first construct a graph 1 to 2. 1 to 2. Not just draw these uh like edges, but it's bidirectional. 2 to 3. Fuck it. Then it's 2 to 3. 3 to 1, right? We have got these 3, and we have 1, 2, 3, 4. What I can do is, like, I need to solve it using BFS, right? So here's the BFS thing, and I will be having a visited array will be like 1 to n names are available from 1 to n, है ना? 1, 2, 3, 4. यार, and it's 1 2 3 4. Initially it's -1. Initially it's -1. So I will move to 1 actually. To bucket, yeah. 1 2 3 4. So first I move to 1. So I saw 1 is not visited. So here I have a constraint, like I can choose 4. Yeah. I can't just do it in a random way. Hence 1 2 3 is a valid answer. Other valid answers are 1 2 4, 1 4 2, and 3 2 1. Wait, let me do. Like I will do BFS of 1. So 1, I will color it with 1 and put it here. Put it here. Now 1 adjacency list. Okay. I need to construct adjacency list as well. 1 2 3. 3 only. 4. So 1 will be 2 3. 2 will be 1 3. 3 will be 1 2. So when I have moved to 1 and I have moved to 1, 1 I will move to 2, then 2 will be unvisited, and 2 will be unvisited, so I can color it, like color it into next, uh like what, next to color next to it, using that rolling concept. So 2 will be there, 2 will be placed here, and 2 will be colored here, then 1, then 3, 1 will be, like 3 will be there. uh, 3 will be there, then 3 is also not visited, then I can color it 2. But when I color it 2, two gardens will have same color, 2 and 3, and this is not valid actually. Yes, this is not valid. So in short, if any of the nodes has, like I have 4 choices, and if any of the nodes has more than 4, then it is not possible to color it according to the given question. So the question comes how, and it is guaranteed. So since they are saying that it's guaranteed, I just need to do thing. I think I got the concept. Like instead of like going to the next, it will be I equals to 0, like 1 modulo 4, then 2 modulo 4, or why to do modulo, because the answer already exists. So it just need to, like, if that if node 1 has two, like two connections, then the first connection will get its next, second connection will get this next, and third connection will get this next. So max to max, one node can have maximum of 3 connections. Otherwise, it will not be possible, है ना? I think that's the concept. Let me just dry run it with another problem. Like we have 4, 1 set 2, set 2, 1 set 2, 2 to 3, 3 to 4, 3 to 4, 4 to 1, 1 to 3, 2 to 4. Will be 1, 2, 3, 4. That's an absolute answer. I just got the intuition here. Okay, so let's jump into the code part. Let's jump into this coding part. And do we need to construct an adjacency vector of int adjacency plus 1? Then we need to keep track of vector and vector and color. One, two, three, four. I less than paths is plus, then we uh, adjacency of u and v is there, int u equals to int is equal to paths I comma 0 and int v equals to paths I comma 1. We need to push like adj u dot push back v and adj dot v dot push back u. The adjacency list is ready. Now let's do it using BFS for int equals to 0 less than equals plus. We just need to start with 1 because 0, there is nothing called 0 here. And color of I is, if it's not visited, then we'll check and we will just do this BFS thing. BFS of I comma BFS of I comma color comma adjacent. That's it. Answer array or like color array. Dot begin plus one. We just need to formulate here something. So I need to make sure what I just need to do some rolling kind of thing. That's yeah, we need what BFS will be there where I will be storing these answers. What is the constraint here? 10 raised to the power 4 and paths dot length is 2 into 10 raised to the power 4. So every garden has at 3. Color will be 1, 2, 3, 4. If it's 1, 1 modulo 4, 2 modulo 4, 3 modulo 4, 5 modulo 4, 1, 6 modulo 4, 2. Since it said it is possible, so I okay, let me just figure out first. Let me just write this private function void bfs and start there pass it vector of oh, so first we will color of start equals to let's give it 1. What can we pass here? It's like, can we pass in the queue like the node and its color? I think it can work. Int comma queue. So queue dot push start comma one. We have just pushed it while not queue dot em empty. Int node is equal to queue dot front dot first. Int color equals to queue dot second. For int equals to less than a node dot size a plus if that node if color of adj node I guess just the color of adj node I equal to -1. If it's not visited, then q dot push what I will ej of node a comma a plus 1 below 4 color of this thing equals to plus modulo 4. This is the thing. Since it said it is possible, then the case done color. I'm just checking if it's working or not. So here it's giving me 0 0 0, but I was expecting something else. Yeah, I think now it should work fine. I did not initial time limit exceeded. Filter in color. This is it. Hey, Q dot pop. I didn't do Q dot pop. Right. So this was the mistake, and I hope. Okay, good. It's giving me 112. Okay, I know it's working, but I need to just take care of my logic. I just need to take care of logic. Equals to 0, I less than it design. 0 set just I plus 1 4 with 0. अरे यार सेट कलर होगा ना आई थिंक कलर प्लस what I'm thinking, what I'm doing. Okay, now it's working. So I just need to return there is one function which it pops up the just you just do it. Let's just make it and here it's fine. Color of will be color right, then color of start minus. Do I need to shift anything there? Because everything is now here derived one. ABS set return color. There is some take it this. Is it working? Not. There is a little bit of the end color begin color dot end. This is just a brute force thing. I will just optimize it. I'm just checking if it's working fine. Okay, still it's a return. It return now. Okay, the two test cases are passed. That Yep, that one issue will be there because I don't have any colored colors named zero. Okay, I get it. Will be like 1 2 3. It give me 3 and 4. Most of the things are fine, but the one thing is not. I didn't thought of this thing. The color is one. For modulo 4 will give me 0. Give it to 0. Let work. Don't know if it. This thing is simplified 2. Simple thing. Where it's expected. Okay. Why is the same problem? It's 2 2. There is some logical flaw here. Think about it. There is that. What am I missing here? What am I missing? Let me just try run it. Suppose I have color equals to 1 and I have I equals to 0 to 2. It will run like this thing. Hmm. It will run to 0. Then if here I have color, I have 1 and 0. So for 2 I will be I should have color 1 hai. I have choices 1 2 3 4. 0 1 2, right? So 0 plus 1 modulo 4 plus 1, the 2 color becomes 2. For this it becomes 2. Now it comes to 3. Then 1 plus 1 plus 1 modulo 4 equals to 3. 3 gets 3. Now 1 plus 2 plus 1 modulo 4 equals to 0. If it's equals to 0, it should be 4. And equals to 0 before. Okay, that was the mistake. Let me just submit it. Oh, I am giving 244 and it's giving 1213. Okay, let's see. Once one is connected to 2, 3 is connected to 4, 3 is connected to 2, 4 is connected to 2, 1 is connected to 4. So I have just given it 1, right? I have given it 1, so 1 say which will be connected like 2 and 4, and it will be 0 and 1, so it will be 1 plus 0 plus 1 modulo 4 equals to 2, so it got 2, then 1 plus 1 plus 1 modulo 4, so it gave 3. Now when I move to 2, there is one mistake. If it's not visited, can I give it like if it's visited, if color start equal color equal, not work. So color of what I am checking is I no need to enforce this thing because this condition will be checked only checked there itself. Yeah, there is one thing. Like when it comes to this, but it's not connected, nah? It's not connected to this. Ooh, I can vote. Color start that will be managed by that entry checkpoint at the main function, so I need not to worry about this. But if it's not visited, yeah, but it may be a part of like it may be adjacent to any other node, so that might cause problem. Okay, the editorial doesn't exist. Ah, shit. Ah, yeah, we have some log issue.